Hello everyone, welcome to this tutorial where we will explore a Python implementation of a page replacement simulator. And this educational tool demonstrates how operating system manage memory when there are more pages and available frames. Today we will break down the code and explain how it simulates four classic page replacement algorithms, that is FIFO, LRU, LFU, and MFU. By the end of this video, we will understand how these algorithms work and how they are implemented in this simulator. And this code we are going to explain has three main components. The first component here is a process class that models page in memory. We also have the page replacement simulator function that implements the algorithms, and a thinker-based graphical user interface. The core of our program is basically this function. It takes three parameters: and the sequence of page being requested, the number of available frames, and the algorithm to use for page replacement. In the initialization, that is basically this part. First, the function is initialize several important variables. The function will maintain a story of all frames set and stack when page false occurs. The main loop. Now we enter the main loop that processes one page at a time. So in this part, for each interaction, we here get the current page to progress and prepare to update the frequent frame state. At the beginning, we initialize all frame as empty. That is basically marked with a P, with the P, or copy the previous state that is here. For each page, we need to check two things. We determine if the page is already loaded in in memory, and if not, we mark it as a page file. Then we check if there are any empty frames available. In this case, we have many cases. The first case is this, that is basically an empty frame available and a page is not present. So if we have empty frames and the page isn't already loaded, and basically we find the first empty frame, that is here, the first empty frame, is using if we are using this algorithm, basically we place the new update the age counters and paste the new page in the empty frame in this part. We have the second case here, that is basically that is not empty frames and a page is not present. This is where the replacement algorithms come into play. So in this part we have FIFO, for example, that is basically first in, first out, is the simple algorithm. We use the my coin as a circular pointer of the next frame to replace. And here uh, we replace the frame with the new page and we move the pointer to the next position with the plus one, wrapping around if it's necessary. The LRU, or less recently used, we increase the age here. We increase the age counters for all pages, and we identify here in this part. We identify the page with the highest age, and we replace with the new one. Here, the last frequency use, we create a list. This is a list. We create a list of frequency counts for each page. We found the page with the lowest frequency, and basically we replace here the page with the new one. And the last algorithm that is most frequently used, basically we create a list of frequency counts. This is a list of get frequency, and we found the page with the highest frequency. We're finally we replace the page with the new one. Here is the third case, that is that page already present. If the page is already in memory, we choose update the counters. For LFU and MFU, we increase the frequency, mm, increment frequency. We increase the frequency counter to the access page. And for the LRU, we basically increase the age of the access page to of increase the age of all pages and reset the age of the access page to 0. Um, in this part, after processing a page, basically we save the current state to our history and move to the next page. Here we save the current state to our history and move to the next stage. And this part, once all pages are processed, basically the function formates the results. It converts the story to a matrix in this part with a numpy. It basically transport the matrix to show each frame as a row. It formats the output showing the original page sequence, the content of each frame at each step, the page foul or not foul, and the total foul count. So we are going to present the code. And here we have the simulator. Basically, we are going to use this example with the 4 frames. And we have here all the algorithm that we can use. In this case, we can check that basically this format that we are working here is this. That is basically how we are implementing the matrix that we make here. And this is basically a string format. We have also can this FIFO, and that's all. Thank you.